The McGill AI Podcast.
Hello, everybody. Welcome to the third episode of the McGill AI Podcast. My name is Kostav. I'm here with Himanshu today, and great sunny day today in Montreal in the start of November. We're really excited to have Professor Jackie Cheung joining us today. Professor Cheung is an associate professor at McGill, Canada, CIFAR AI Chair, research with Mila, the Reasoning and Learning Lab, the Center for Research on Brain, Language and Music, and the Center for Intelligent Machines. Professor, thank you so much for taking the time to speak with us today.
Thanks for having me.
So today we're going to be talking about a variety of different things about your research interests, about the history and change in the field of NLP, the current state of NLP, common sense reasoning and summarization, and of course, the ethical aspects of that research and advice for students looking to get into the field. But why don't we start out with a little bit about yourself, Professor? Can you tell us a little bit about your personal background and your journey into academia?
Sure. Yeah. So I did all my degrees in Canada. I did my undergrad at UBC and then my graduate degrees in Toronto. And what motivated me to get into the field of NLP is really different languages and maybe linguistics as well. So growing up in Vancouver, I was exposed to many different languages. So with my family members, I spoke Cantonese, and then also had to go to Chinese school and learn Mandarin. And then, of course, with my friends and environment, I spoke English and I took other languages in school. So what really piqued my interest and curiosity was that all of these different languages, they all sound so different. They have different rules for grammar and structure and so forth. And yet you can use all of these languages to essentially say anything that you might want to say in a human language. So I found that really fascinating. So I took that interest with me into undergraduate studies, and I did a dual degree. I majored in computer science, but I did a minor in linguistics and a minor in German. And that got me started into the field of NLP, and I got research experience there and then continued into grad school to do NLP research.
That's really fascinating. And did you always know when you were an undergraduate or maybe even earlier that you always wanted to be a professor, or did that change throughout your studies?
I would say that I wasn't 100% certain, but it was certainly one of my top choices even early on. And it was just because I was motivated by learning more about language and discovering new things about language and language technologies. I did do internships in industry, but they were primarily research internships, and they were really fun and exciting. It also made me realize that I don't want to be working on products and development for my own personal career, at least not for the majority of the time. It turns out that now I have contacts in industry, and I sometimes do consulting for industry in language technologies, and that's also been very fun and illuminating. But at least for me personally, I'm much more motivated by research on the research side, to look at thinking about new problems to solve, finding solutions.
And how exactly did you know that AI was the main sort of mode by which you wanted to pursue that linguistic research?
Yeah, well, my other passion growing up was games and computer science. I guess it's probably it's not such an uncommon thing. And so I was interested in finding out if there were more formal and algorithmic ways to think about human language. And it turns out that lots of people have spent lots of time thinking about this topic as well. And so computational linguistics and NLP is just the right field at the intersection of these two interests of mine.
Yeah, I would definitely say there's a pretty large overlap between gamers and people who are in computer science. In fact, I took a class under Professor Cheung, Comp 424, Artificial Intelligence, where our final project and a lot of the ways in which you explained the formalisms behind the introductory principles to AI was through the language of how you play games. So that's very interesting. So We're going to move on to your research questions. Himanshu, you want to take the first one?
Yeah, of course. Just before we do that, Professor Cheung, I just was hoping that you could clarify to us the difference between what NLP is and computational linguistics is. Because you mentioned that a couple times in your previous answers, and I feel like it would be really nice.
Yeah, for sure. So computational linguistics tends to refer to the more scientific aspect of the field, which is to use computational methods and computational modeling to understand how human language works from a scientific perspective. Whereas on the other hand, natural language processing tends to refer to the human language technologies and what we can do with these algorithms, which should be something useful that we can all benefit from. And so there seems to be a bit of a science versus engineering divide here. But on the other hand, many people use the terms almost interchangeably. And so I might do that as well. I might use them interchangeably, but there are different connotations between these two terms.
Thank you for the clarification, Professor. Okay, so now getting a little bit more into your research. Broadly, what does your research exactly focus on? And how do you go about finding the problems and research topics that you want to sort of explore?
Sure. So at a very high level, in my research lab, my students and I work on this idea that the structure of human language should somehow relate to the structure of the world around us. So in the world around us, we can talk about how there might be different entities, there might be people and locations, and there might be events as well, and relationships between these entities. And so there's a rich structure out there, and that can be one way of modeling how we understand the world and how we think about meaning. So what I'd like to do is to think about natural language in a similar way, in that you have natural language structures. So in natural language, you can talk about words and you can talk about syntactic structure and how words relate to each other. And I like to find algorithms and techniques and methods that can map between the linguistic structure that we find in language versus the real world structure that we can use to describe entities and events and relations. So really fundamentally, that's at the core of a lot of what I do in research. And so that encompasses a lot of my work recently on common sense reasoning, where you have linguistic structure and there's maybe a ambiguity resolution task. So one thing that natural language is famous for is that you can have the same sentence and it can have multiple meanings, or there could be multiple possible interpretations. So I like to figure out how, if you have a better model of the world, how that can help us with linguistic ambiguity resolution tasks. So one example comes from something called a Winograd Schema challenge, where you have a pronoun and then the interpretation task is to understand what the pronoun refers to. If you have something like the trophy couldn't fit into the suitcase because it was too large, then we would like to understand what the pronoun it refers to. So because of our understanding of how the world works, we know that it here refers to trophy. On the other hand, if we said the trophy didn't fit into the suitcase because it was too small, then we should understand that it's supposed to be the suitcase. So that's one avenue of my research. The other major area that we can also talk about is in automatic text summarization. So here the goal is that you have an input piece of text, and we'd like to model the meaning of the text and figure out what's important to people, and then to condense that down into a shorter version of that text itself. And we've been looking at problems in automatic text summarization as well.
So we heard a little bit about where your focus in research right now is. We were wondering, has it changed over time?
Yeah, that's a great question. So I would say that my research focus has shifted a bit over time more towards thinking about what we should be working on and how we evaluate what we should work on in terms of NLP problems. So for example, one thing that many people start off working on in the field is to work on an existing benchmark evaluation and data set with an established evaluation measure. And then people can talk about designing new methods that can work better at scoring high on these standard benchmarks and evaluations. And that's very valuable, and that's how we've gotten a lot of advances. And then over time, what I've shifted more and more towards thinking about what are some of the challenges and problems that we can throw at our NLP models to see what they can actually achieve, and also to assess and critically evaluate the performance of the models more than just looking at their performance on a single evaluation measure on, say, a small number of benchmark data sets. Because I think a lot of the time, the average performance of a system can now be very, very high with modern NLP methods, but there can still be ways in which we can probe them and get them to behave in ways that are quite unhuman-like. And so I think that's a very interesting avenue to actually understand what the current methods can do well and what they cannot do well through a more targeted kind of evaluation.
Absolutely. I think that work is super important because oftentimes we see a lot of modern language models get heaps and heaps of praise for being able to perform well at certain tasks. But really, in order to achieve generalization or have confidence in these systems to be applicable to use in daily life, it's very important to sort out the kinks before they're sort of deployed. And we're going to have some questions regarding the challenges with deployment later as well. What would you say so far you're most proud of in your research and work?
Yeah, I guess I'm proud of many different things that my students have done. But if I were to single out one thing from the past few years, one thing that I've been proud of is our analysis of claims about performance on common sense reasoning benchmarks. So the example that I gave earlier about pronoun resolution and the Winograd Schema challenge with the suitcase and the trophy, that was part of this evaluation data set consisting of very, very hard questions that were human written and collected into this set called the Winograd Schema challenge. And the claim is that an NLP system would require so much knowledge to solve this task that solving it should amount to passing the Turing test. A few years ago, some researchers came up with methods based on using large-scale pre-trained language models. And they had a clever way to use these language models to solve the Winograd Schema challenge at performance numbers that appeared very, very high, much higher than random. Not quite at 90% or 95%, but still very high, like 80s or so. And so my team, we were very suspicious of these claims because we had tried something similar. And so we did some work to actually seriously understand this claim. And what we did was that we used some of the similar methods, but we subjected the methods to slightly altered versions of the questions. So for example, in many of these resolution questions, they contained proper names. So like Bob or Jane or other names that are there in these questions meant to represent just as a name to point to an entity. And so what we did was we performed experiments where we swapped the order of the names, we changed the names themselves, and we tried to look at whether the pre-trained language models would behave differently based on how we changed the names. So the idea is that if the names are just there to point to an entity that is specific to that context, then just changing the name shouldn't really affect anything. But we saw through this study and a bunch of other related analyses that the language models were heavily affected by these changes that shouldn't really matter. And so that's some evidence for us that the pre-trained language models, there might have been some kind of data leakage or some other kind of overfitting to this particular evaluation data set. And so we were able to assess this claim and show that although the numbers are very high, it's not really clear why they're so high. And it's possible that in that particular set of experiments, the pre-trained language models were not actually understand the real world context in order to solve these questions. And so, yeah, I'm quite pleased with that work because I think it's a good example of how, with a little bit of careful critical thinking and evaluation work, we can really assess some of these claims that can feed into the AI hype cycle.
And just to clarify for our listeners, why is it important that these models are able to generalize? Why is that important in practice and in application?
I think this is one of the most important and critical things in AI and AI technology that we have to think about right now. And it's because the average levels of performance can hide the fact that once in a while, the models can fail quite spectacularly. So one of my colleagues recently pointed me to this example. So this is a colleague from Microsoft Research, Alexandra Olteanu, and she pointed out this example, which is how a summarization system might fail spectacularly. So it was a health article about what to do in an emergency situation. I think it was if someone was having an asthma attack. And then in the original website, it said things like, do not do the following. And it listed a whole bunch of things you're not supposed to do to try to help the person suffering from an attack. But in the summary of that article, the summary omitted the do not do the following part. So it gave you a list of all the things that are exactly what you're not supposed to do. And so I think this comes from a lack of understanding of the context and of the semantic representation of the text that can tell you that negation is really important and you cannot omit it. And so I think this goes to show that you have to stress test the systems and you can't just rely on average performance because this can have real world consequences that are quite disastrous.
Absolutely. I think this was a meme that was trending on Twitter last week where people were like, hey, good job, Google. Great work on your summarization algorithms. Oh my God. So we have a couple of questions regarding the history of natural language processing research. So to start off with, could you give us a brief history of the different language models that were used back in the day and the changes in architecture that allowed us to get to where we are today?
Sure. So in terms of the history of the field of NLP, I would say that language modeling was certainly one of the major tasks that has been the focus of NLP, but it was not the only one. So let's just be clear, a language model in a technical sense is not just any model of natural language. A language model in a technical sense is a model that can predict the next word that should appear in a context. And so this was one of the major tasks in NLP. And originally, the idea was that these language models should be useful in a relatively restricted number of downstream applications, like automatic speech recognition or machine translation or maybe summarization. And so in terms of the earlier methods focused on discrete treatments of the words themselves. So a word, the identity of a word, like cat or dog, is the word itself. And then you associate any statistical patterns that you got from a training corpus, from a training sample of text, just with that word. And so a lot of the early work was of this flavor. And there was a lot of work on trying to use smoothing techniques to overcome issues related to sparsity and related to the fact that the model size can increase a lot in terms of the number of parameters. And we don't have a lot of data back then. And we also didn't have a lot of computational power. And so all this started to shift with neural networks becoming extremely popular. So these methods started becoming very popular So in 2013, we had word2vec, and we had methods that showed that you don't have to treat every single word as being entirely unrelated to every other word in modeling their occurrences with their co-occurrence statistics. And instead, you can model them as points in some vector space so that they can share statistical strength, even if that particular word doesn't appear in a context, if related words appear in that context. So word2vec showed us that this was all possible in 2013. And then a few years later, then neural sequence models, recurrent neural networks, became really popular, and those really paved the way for modern language models. So the most recent iteration of this would be with BERT and related models. And then with these models, they're based on a style of architecture called the transformer architecture, where within a particular sequence, any word pairs can interact with each other to produce statistical signal strength that can be then propagated further down in other layers of the transformer. And these types of models do so well at language modeling that people are now trying to understand what else they can be used for. So whereas originally language models were meant to be this thing that can help us guide automatic speech recognition systems or machine translation systems, now people are realizing that actually they can be used for many other things. And so now we see them all over the place, and we also see them being used as a precursor for actually classification systems, where you can take a transformer language model and you can then fine-tune it to further train it on discriminative tasks where you have to predict between multiple categories, like in a task like sentiment analysis, for example.
I see. And as this evolution has been happening, what is the trend with the number of parameters and the size of the data sets that these models need to be trained on?
So it's definitely exploded. So now it's unimaginable. The number of parameters and the amount of text that the current generation of language models is trained. In fact, it's gotten so expensive and so large that only a select few companies and institutions can even afford to do this. And now even in academia, it's not very feasible to train from scratch some of the latest versions of these models at the same scale as in industry. And so that kind of presents a bunch of interesting questions, like, is that good for the development of the field, that there's such a small number of players who can train these models and have all this power? And what is the nature of academic research in universities versus academic research in companies? So that raises a new set of questions.
I also had another clarifying question with that I feel like I always trip over when it comes to natural language processing. And it's, you've spoken a little bit about different language models. And I was wondering what exactly is the specific definition of a language model? Because, for example, the two things that come to mind right now for me are you have sentiment analysis models. Like, would that count as a language model? Because you mentioned something about how language models are usually something that can predict the next word coming in a sentence, right? And that reminds me of like OpenAI's GPT-3. So would the sentiment analysis or a simple text classification algorithm still be considered a language model or not?
Yeah, so in a technical sense, a language model is about predicting a word in a context, canonically the next word in a context. So a sentiment analysis system is not traditionally thought of as a language model. Sentiment analysis is usually given an input passage, predicts something about what people think of that topic, like positive or negative. So that's something more structured like a classification problem, where you have to decide for each input passage which of these buckets it falls into. However, with the recent language models, what you can do is you can pre-train the language models as a language model, so in order to predict words and context. And then you can take the parameters of that neural language model, and you can then change its use and change its output so that its output should now be about solving a classification task. And so then this is called fine-tuning. And so you fine-tune it on this additional set of data, which is about sentiment analysis or whatever you care about, and then you get it to then make these classification decisions.
Okay, so similar to in computer vision, where you might have a model that is trained on a specific set of classes, and then you fine-tune it to predict like an additional class. Okay, very interesting.
Yeah, I would say one difference is that in natural language processing, the variety of tasks that we have, I would say, tends to be greater. So predicting a word in a context, essentially, if you have rare words or out of vocabulary words, each of those new words is kind of like an unseen class, right? In the sense of identifying. So whereas so we consider that all part of language model, same task in NLP typically. And so for us, the different tasks might be solving very different things. It might be solving sentiment analysis on the one hand. It might be answering questions. And even within question answering, it might be about answering very different styles of questions. Is it like factoid questions, like trivia questions, or is it like questions that require analysis, synthesis of content? I would say because language is so flexible and can express so many different ideas and topics, the kinds of tasks that we can define that fit in NLP are also.
Okay, so from everything we've spoken about so far, it's been very blatantly clear that natural language processing isn't exclusively computer science or isn't a field that's only focused in like algorithms and stuff. So we were wondering if you could talk a little bit about the intersection of natural language processing with other fields, for example, such as like cognition, linguistics, neuroscience, or anything else that comes to mind.
Yeah, sure. So I would say that natural language processing and computational linguistics in general, it started off being very much influenced by linguistics, as the term itself might suggest. And so a lot of the earlier work in early theories directly build of theories that linguists like semanticists and syntacticians have developed. And then a lot of earlier work in NLP has been about devising ways to parse into those formalisms or to understand like what are the consequences of adopting a particular formalism in terms of learnability effects and so forth. So more recently with neural networks and neural modeling, that's still happening. But now a lot of the attention is being turned to like applications and what we can do with neural network models, and that's great. And going forward, I see a lot of connections with fields such as sociology and psychology, because now we're deploying these systems into the real world, and we need to talk with other people to understand what their potential effects are in the real world. And so for that, I think that would fall into these two fields and actually much more than that. For example, in health applications, then we would need to start talking with doctors and other clinicians and patient groups and so forth, and even potentially like politicians and so forth, right? So I think now that methods in NLP and machine learning are actually working, at least in general, in many settings, now the connections will actually be much greater than before. Let's see, if I can give a particular example, I might talk about, say, issues related to fairness and bias. So then in this setting, we might have NLP systems that might be trained on some language in its training set, and maybe the language itself is in some way biased or unfair. And if the NLP system that you then produce is itself biased or unfair, then whose fault is that? Is that really the fault of the NLP system designer, or is it like the fault of the people who wrote the original training corpus with them? And how do we account for that? And so we might have to talk to people in law to deal with that. Or how do we actually just define bias in the first place? That might be something that we should ask psychologists and sociologists about. So those are some examples of how the number of interactions between NLP and other fields I see is just growing quite a decent in the next few years.
I think that is a very important thing to mention, that not only is the field influenced by a lot of people who aren't like pure computer scientists, but when it comes to practice, there's going to have to be a lot of collaboration between people in a vast number of fields in order to create the right protocols, create the right assessment metrics, in order to ensure that these technologies are being used ethically. I was wondering, there seems to be a conception that we don't have any systems that are deployed that could actually have like harmful effects, right? Could you maybe talk about current uses of NLP models that people might be using maybe on a day-to-day basis or less frequent basis?
Sure. So I think one thing that's peculiar about AI in general is that as soon as something becomes widely deployed and integrated, people stop thinking of it as intelligence. But really, we already have a lot of AI systems and AI techniques that have been deployed and integrated into our lives. So one of the classical examples might be information retrieval and web search queries. And so we just don't give a second thought to that because we all use it every day and it's quite successful. But there could be ethical implications or fairness or bias implications even within that system. So for example, if such systems are trained to return results that are most typical of the search query terms that you give it, it could be that what's typical for a particular search query could be biased in some way, just because maybe there are certain associations, for example, between occupations and genders. And so if the search result ranking is based on typicality without any thought about, say, these demographic characteristics, then it could be that you rank the most typical people holding an occupation higher than others who are not typical in terms of those demographic characteristics. And that would be an example of unfairness. So it could be that there are two people who are equally relevant, equally qualified, whatever you want to do, and their search ranking results are biased just because one of them happened to be in a majority group and the other does not. And so it means that even for something that's very well integrated and deployed, there could be ethical or fairness concerns that we have to examine and figure out. So at the very least, we should start by, and people are, looking at trying to measure and evaluate these issues of bias and fairness within deployed systems and within systems that are being developed by researchers. And then we can start talking about how do we develop criteria for fairness and how do we enforce that within our systems. And so these are all topics of active research that many people are working on.
Okay, so we've spoken a little bit about the intersection of different fields. And what's really interesting with NLP is that when you look at language, it's so subjective. But when you look at like machine learning and artificial intelligence algorithms, they're so objective. They're so set in like certain truths, and you really need to define all of the characteristics to get a model that's really successful. So a question I have is, how do you take these textual data sets and mathematically transform them into data that we can actually train machine learning models on?
Yeah, well, if you think about it, language, you can think of it as information. And information we know can be encoded. And information can be encoded in such a way that we can process it and find regularities in it. And so language is no different from anything else in that regard. So for example, you can decide to index every single word. So suppose we're working at the level of words. You can decide to index every single word, give it some number, and then you can start associating statistics and characteristics with each of these numbers. You can also start defining patterns that you see based on groupings of words that seem to behave similarly. And so all of that can involve statistics and can involve regularities that can be learned, that can be discovered and learned. So I think it's interesting that you say that language is subjective, because I agree that language, everybody uses language in a slightly different way, and we can use it to express such a wide variety of topics, including opinions and so forth. So from the perspective of an NLP researcher, we think of it as language is this phenomenon, and we can try to model it and do useful things with it. And so then we have to account for the fact that there could be, in any particular context, multiple interpretations of a particular passage, and that there could be multiple following consequences or following sentences downstream that you could try to predict based on this. And so that's part of what makes language really interesting to work on. But in terms of the modeling process itself, I would say that we can still try to find criteria. Some of these criteria could be subjective in terms of the quality of an NLP system, and others could be objective, and we could talk about, say, the similarity between this piece of text and some gold standard piece of text. And so the modeling process, we can still think about it using math and statistics and machine learning and all of that, even if the types of phenomena we're dealing with could involve opinions and could involve ambiguity and a diversity of possible interpretations.
At the start, we spoke a little bit about the Winograd Schema challenge, and we were wondering what aspects of these challenge do state-of-the-art models succeed on, and what aspects do they fail on?
Yeah, so in terms of this Winograd Schema challenge, it's already specifically designed to be very hard for statistical models to solve. And so in that sense, it's kind of a wonder that our methods can get any level of performance on them at all. And so to the extent that they can, it might suggest that there are some regularities or biases in the data sets that the models are exploiting, which were not intended to be there by the designers of that Winograd schema challenge itself. So for example, there could be biases. Like you can talk about there is something that's famous. Is it a map or is it a treasure? And so then you can learn through statistical reasoning that treasures tend to be more likely to be associated with the word famous than maps. And you can solve a question, a Winograd schema challenge question that way. So this is a type of simple statistical association that's not supposed to be part of the Winograd schema challenge. And so we found that actually these statistical associations do exist in this challenge data set. And the current NLP models are extremely effective at exploiting that and doing well on that. And so this is great. This is not really a defect of language models or language model-based methods for solving these tasks. Rather, this is saying that this is a type of thing that the current models are good at doing. And this challenge data set was supposed to be testing for something else. And some of the questions, at least, don't seem to be targeting that something else. And that something else is meant to be something that relies on our general understanding of the world and how the world works in terms of what types of entities tend to participate in what types of relations in like sequences of event chains.
I see. One of the things that we were really curious about was, are there issues in trying to generalize these models for different languages? And can you give us like a brief overview of how a popular platform like Google Translate works?
Sure. Yeah. So I think there are two parts to that question. So the first part was about generalizing our models to other languages. And by far the biggest issue is that other languages don't have as much data that is written in those languages as other popular languages do. So as we talked about earlier, the current generation of models are very data hungry. They will consume as much text as you can throw at them. And these models rely on a large number of parameters along with a large amount of training text in order to achieve the very high levels of average performance that we see. And so in terms of the world's languages, by some counts, there are like 6,000 to 7,000 of them. And for the vast majority of them, there does not exist an internet that is of a comparable size as the English language portion of the internet. And so already that means that the methods that we have won't directly transfer because we can't just run the same model on an equivalent amount of data and get good results. And so that's a really major challenge. The other challenge could be that other languages have different kinds of structures and properties than English, which means that the types of models that we are using for English or other major languages may not transfer directly or may not transfer as well. So let me give some examples. So one example could be from, say, like, even though this is a major language, this point still applies. So for, say, Chinese. So in Chinese and a few other East Asian languages, like Japanese, there are no spaces between words. And so word boundary detection is itself a task in Chinese that you might have to solve before you can start applying methods that assume that there are words, that the inputs are words. So you can have other tricks, like you can just do away with this assumption that the basic unit of modeling higher level structure is words and use something that's lower level. So that's one possibility. But still you might be missing out on, or you might have to solve other sub-problems before you can get the same level of performance as a system that was originally designed for English. Another way in which languages vary is in terms of the amount of content that's explicitly written into a sentence versus the amount of content that's supposed to be inferred from background context. So in many languages, for example, pronouns are normally dropped and you don't state the pronouns explicitly in the sentence. And this can cause problems with systems that rely on having explicit pronouns in the sentence to know that there's something there. There's an entity there to be resolved in the first place. And so this is another issue that can cause major problems because you need to rely on context to figure out that there was supposed to be an entity there. And for people speaking those languages, it's super easy because it's just extremely natural. But for NLP systems, this is something that you might need to have a separate module. So that's another example of a phenomenon where you might need something language specific, at least in terms of the problem definitions. So I think the second part of your question had to do with translation, machine translation. So machine translation and how that works is also right now based on using large amounts of textual data. And it's by using the same kinds of models that we mentioned before, like transformer models and recurrent neural network models, that we get very high levels of performance, at least between popular language pairs. And so then these methods are trained on a lot of parallel texts so that they can figure out statistical associations between not just words in the different languages, but also words and their different senses between languages. And also, in general, machine translation is a many-to-many mapping problem between the words in the two languages, between the source and the target language. And so these methods are very good at finding these very complex patterns between the languages to generate the output translation.
Got you. That was super interesting. I've never actually considered before that obviously there's a lot of pre-processing that comes about with natural language processing, but in some languages you might not even have separations between words. So to figure out those boundaries and a lot of the other stuff that you talked about, it honestly points more towards the fact that we need more interdisciplinarity in the field so that people would come up with clever ways in order to face those challenges, right? So we wanted to talk about some of the other research that you mentioned at the beginning. What are some ways, because as you've spoken about, there are so many challenges that come about with many of the applications of natural language processing, what are some of the ways that we can integrate common sense reasoning into models?
Yeah, so what we're working on right now is to incorporate structured knowledge bases that people have developed about the world. And we would like to incorporate that into our NLP systems. So for example, a very simple kind of knowledge base, which is very widely used and still quite informative, is something called WordNet. So WordNet you can think of as essentially like an expanded thesaurus where you have words that have a lot of their synonyms grouped together. And you don't just have words and their synonyms grouped together, you also have relationships between words in terms of other lexical semantic relations. So you can have synonyms, but you can also have antonyms, so words that mean roughly the opposite thing, like good and bad. You can have like hyponyms and hypernyms, like a rabbit and a mammal. So a rabbit is a mammal. So there's like a rich structured resource of WordNet that's out there. And there are other resources that are more complex in other interesting ways. But the basic idea is that these resources, they link together words by relations that are not just about co-occurrence. So if you have a rabbit as a mammal, then that means that a rabbit should inherit some of the properties from being a mammal. And it might also have its own interesting differences from like the typical mammal. So we would like to exploit and use these kinds of structures and integrate them into NLP systems because this is a different kind of knowledge where it could be very difficult to acquire the same kinds of knowledge statistically through examining corpora. So we think that there's a lot of opportunity there to come up with models that don't require nearly as much data in order to get better generalization performance and better performance overall on those adversarial or difficult cases that we're testing our NLP systems with. And I think the other aspect to this is also on the modeling side and the model architecture to start creating more explicit modules and parts of the system that are not just about word prediction in a monolithic architecture. So I think that maybe goes a little bit against the trend in the past couple of years, but I think this is still important to do. So in other work that we've been doing recently, we've looked at tasks that involve something called theory of mind in the psychology literature, which is the idea that people understand that other people and other entities have their own minds, they have their own mental states, and they have their own beliefs and desires and intentions. And so that might mean that different people might be in the same situation, but because they have different access to knowledge in that situation, they have a different understanding about the world there. So they might have different beliefs about the location of an object, for example. It's a very simple example. And so then we've worked on building that type of idea into a neural NLP system where we have different parts of the neural network model that are responsible for storing the information states of different entities over time. And so there we're building a little bit of structure and we're adding a bit of that structure back into the model in a way that lets the model more easily figure out that there can be conflicts between different entities, points of views, and their knowledge states. And so those are some examples of how I think we can build different kinds of common sense into NLP systems by adding more structure, both in terms of the types of knowledge we feed into the systems and in terms of the architecture of the model itself.
I think it's so fascinating that a lot of the field comes down towards trying to figure out how people perceive language and what are the sort of agents and conditions by which people understand language and applying that computationally. I think that really is the crux of what computer science and engineering is taking things from a real world and trying to automate it into some form of digitization or something.
Really quickly though, Professor, we've already touched slightly on the ethics related to machine learning research so far, but more specifically, do you think that current undergraduate and postgraduate curriculums do a good job in making students think about the ethical implications of science and engineering work, especially because in today's day and age, the ethics behind everything we do has become so important?
Yeah, that's an interesting question. I think we're beginning to adapt our courses and our curricula towards including more discussion about ethics and bias and fairness and so forth. We're probably not doing quite enough. And there's probably still work to go on that front. So I think the thing is that the field itself is just shifting towards thinking about these issues at the forefront of research on the machine learning side. So of course, there are other fields where they've been talking about this since forever. But on the machine learning NLP side, it's the past few years when we've started seriously thinking about these issues a lot more. So I think it'll take time for that discussion to happen and for these changes to happen to the curricula. I think that a lot of the issues that we have talked about in the past have been to do with the ethics of how we do research, right? So we want to make sure that we're not exploiting anybody in our experiments, we're not unfairly using their information and their data, and we're not breaking anybody's privacy by releasing data sets. So that's one angle that has been of a long-standing concern. And I think the other angle, which is what everybody is becoming much more aware of that we have to think about, is the downstream effects of our work, of our systems, and of things that we release. So for example, I think one fear that many people have is that, okay, so now we have this push to open source all of our code and all of our models, and I think that's great. But if it's released by an academic researcher intended for use by other academic researchers, and it's picked up by a company that just uses it in a product without maybe even telling us, they might not be able to understand the implications of just running that model and applying it to some data. You can imagine that maybe somebody takes a pre-existing model and then uses it in a company to come up with a predictor of how successful job applicants might be at their company. And there could be all sorts of biases and ethical concerns there. And it's hard for us to control what happens with the stuff that we release. And then the company might be using this without being aware that there's lots of issues there if they don't consult with people who are well-versed in these issues. So that's an example of a downstream effect that is really concerning, and that I'm not sure we're training our students to be fluent in enough for at the moment.
Interesting. A lot of the issues that you pointed out seems like there aren't really any solutions for. So given that we know for a fact that we can use a lot of NLP and a lot of the research that is going around surrounding the field to actually do a lot of good things, how do we balance that progress and innovation versus realizing that there are some serious downstream effects that can potentially occur? What do you think is the way forward in terms of, do we want more regulations? Do we want more documentation on the research side? What do you think are the most important things to sort of focus on and address?
Yeah, so I wouldn't say that I'm hopeless or that there are no solutions to some of the problems that I raised. And I think it's exactly as you say, we need more standards. Possibly this might involve regulations in order to help us, for example, protect privacy and to help us address ethical concerns to do with bias and discrimination, to help us help figure out who's responsible for ensuring fairness and safety of NLP systems that are deployed. So I think we can set up environments and systems and have incentives that can be partially legal and partially just voluntary standards that people adhere to help us improve the situation, or at least document the potential issues. So yeah, I'm not entirely hopeless about this. So certainly education is a part of this, but I tend to think that we need policies to really guide things to guide us and to guide both the research community and deployments of NLP systems.
All right. Thank you, Professor. That was very interesting to hear. So our last segment of the episode is usually dedicated towards students. So what advice would you have for students trying to get into the field of AI, or more specifically, even the field of NLP?
Yeah, so I think it's a really exciting area. So some of my advice might be to start working on interesting projects on your own. There are many students interested in the area, and there are many resources that are available online. So I think you should pick something and start going for it. So I guess going back to when I said I was interested in games when I was young. Well, I started to learn programming because I wanted to program a game on my own, and that was fun, and I learned a lot from it. And it wasn't for a course credit or anything. So my advice would be, if you're interested in AI in general, now you can do a lot more. So there's games, and if you want to work on games in AI, there's certainly that opportunity. But there's so many other things you can do now with AI and with simple methods that you can play around with and try out. And I think developing that portfolio on your own could also help you find a good research position. Because I know that those are becoming extremely competitive, and it's a source of stress for many students. So having your own portfolio can help you get a leg up. And the other advice I have is to be more diverse in terms of the kinds of problems that you might be interested in. So as I said, in NLP and AI, things are being deployed in many different application areas. So that means there are many opportunities for research and for progress exactly in a lot of these applied areas. So it could be as diverse as something in like some of the standard science subjects like chemistry or physics or biology. It could be something related to health. It could be something related to psychology. It could be something related to engineering and security. So there are so many different potential application areas. I'm sure I've missed many that are also out there. And so it's good to broaden your perspective and take courses in different areas and think about what are some of the other problems that you could apply AI techniques to.
Absolutely. It's important to emphasize that with a background in computer science or artificial intelligence or any of the sort of fields that we talked about, neuroscience, linguistics, you can use that expertise to apply to any given area. And of course, you've mentioned a lot of the applications, but it really could be applied towards anything. And that is the big sort of benefit of AI. Being someone that has worked both obviously as an academic researcher, but you mentioned you did research internships in industry, what would you say some of the differences are between those?
Yeah, that's an interesting question. I think that there might be a larger difference between specific positions in academia and specific positions in industry, rather than simply being a distinction of academia versus industry. So for example, in the industry labs that I did internships at, they were still very academic, and I still had a lot of freedom to work on what I wanted with my mentor in those labs. In general, in industry, there are research positions that are very free like that in AI and machine learning and NLP right now. There are also many others that are less free. And that's not necessarily a bad thing. It could be that they're just targeting a particular timeline or a particular product release rather than for targeting publications. It depends on the kind of work you want to do and how you want to contribute your knowledge and skills. Yeah, so that could be a difference. In academia, as a researcher, you don't have absolute freedom, but you have perhaps on average more freedom to work on what you want to. The reason I say you don't have absolute freedom is you always have to think about getting additional grant money to fund the research and to get resources to complete your experiments. And so you have to think about that aspect. So it's not perfect freedom, but that tends to be a longer term kind of constraint. So you tend to have a lot more flexibility, at least in the short term, to work on what you want to work on. In industry, it depends on the position. You can have a lot of freedom in terms of having lots of resources. And depending on the position, you may or may not have freedom to target the problem that you work on. And you also have to think about, in that particular environment, what are the evaluation metrics of success for your position.
Now, a little more informal, I would say, is what are some things you did outside of work and projects and building your portfolio as a student? And furthermore, do you think it helped your research?
Yeah, I would say the most important things are just being interested in other topics that are not directly related to your research. Yeah, I guess for me, that might be, say, linguistics, and that would be maybe that's cheating because that's even a little bit related to my research, but like just other ideas and being interested in like, I don't know, philosophy or something, or interested in optimization or so find something else that you're passionate about. I think that's important. And it's important because down the line, eventually, it may help you with a particular research problem that you have that you never thought would be related. And also, I think it's important because it just makes you a more well-rounded person, so you're not completely focused on a particular style or metric for success. Because I think it's very narrow to reduce researchers to like people who publish papers. And so there are recipes where you can crank out lots of papers that are all like of the same style. And I think that's like maybe less interesting. So each of them might be valuable, and I think incremental research has value. But you might also want to like think more broadly about ideas that are wild or out there. And that would mean that you have to read and be interested in very different things than what you typically work on. And the other related note is to have a good social network, because I think that's really important for your development as a person and to have like support for your mental wellness. And again, you never know, like down the line, there could be many opportunities that arise because you knew somebody or you're friends with somebody from before. So a lot of my current collaborations are with people who I admire, who I got to know many, many years ago in entirely different contexts. So that's another piece of advice I have. Don't just be isolated if you can, and not think about other people. Try to connect with other people on their terms and try to do it in a way that's not so transactional in the short term.
Absolutely. Those are fantastic pieces of advice, and we can't recommend not isolating yourself, of course, but also just having an interest in various disciplines. And I think the reason we come into university is really to learn. And sometimes because of our hectic class schedules, we sort of gravitate and focus and specialize towards one thing. But because of all of the reasons that you mentioned, the interactions with different disciplines that have helped in your research is very important, especially if someone wants to go into the field of AI, that they explore all the information that is available to them at university through friends, but also through many, many online resources as well. So I just want to conclude by saying thank you so much for taking the time to talk to us, Professor. I think NLP is one of the most fascinating, but at the same time, one of the most challenging fields that people are working on today. And we want to compliment the work that you're doing in making sure that it's done in a safe, ethical, effective manner. Do you have any parting words?
I think that actually you brought up that one point, which I really agree with, which is that there's something that an industry lab can never replicate, which is the sheer diversity of the people and the fields and strengths that you can find in a university, especially a good university like McGill. Even at the best, most well-resourced labs, I doubt that you'll find people in fields that are as diverse as like theoretical computer science and math and psychology and law and in health. You would never find all of those kinds of experts in the same place where there's a relatively easy way to connect them with each other. So I think really that's one of the key strengths of a university and being at a university. And it's something that we need to continue to exploit.
Professor Cheung, thank you so much for taking time to speak with us today. Everybody do Comp 550, Natural Language Processing. Thumbs up from both of us, as well as Comp 424 AI, one of my favorite classes at McGill.